I'm going to be walking you through this time of flight mass spectrometry question. Pause the video now and have a go at the question yourself. So let's find the velocity that the ion travelled at within the flight tube. That's going to be distance over time, or displacement over time. And we want to find in meters per second, as this is over here. So we're going to have to convert the centimeters into meters. That's going to be 0.95 over 9.47 times 10 to the minus 4. That equals 1003 meters per second. So we want to find mass from this equation. So let's rearrange it to make mass the subject. First we'll multiply it by 2. So that's 2 ke equals mv squared. And now let's divide through by the v squared so we get the mass on its own. That's 2 k over v squared equals mass. So now we'll substitute all of our values into this equation to find the mass. So the mass equals 2 lots of 7.02 times 10 to the minus 20 over v squared, which is 1003 squared, and our mass will be 1.396 times 10 to the minus 25 kilograms. So it gives us our value in kilograms. Of course we can't use the equation moles equals mass over mr in kilograms. It has to be in grams, so just multiply it by 1000 to get 1.396 times 10 to the minus 22 grams, which is what we want. This is the mass of one ion, and we want to find the mass number of this ion. And the way we're going to do that is we're going to multiply this by Avogadro's constant. So 1.396 times 10 to the minus 22 multiplied by 6.022 times 10 to the 23, and that equals 84.04. Because we know that the mass number of the ion will be the average mass of 1 mole of the ion. So we're going to multiply the mass of one ion, which is this, and Avogadro's constant, which is the number of ions within a mole, and we get this, which is the mass number. But of course we can't have 0.04 in the mass number, because a mass number has to be a whole number, because it's the total number of protons and neutrons within the nucleus of the ion. And we can't have point something of a proton or a neutron. We're going to round it to the nearest whole number, which is 84. So the mass number of this ion, Sr plus, is 84. So in blue I'm going to go through each singular marking point. So you get 1 mark for finding the speed. You get another mark for finding the mass through this equation. You get another mark for multiplying it by 1000 and getting the mass of one ion. And then you get another mark for getting 84.04, and then the final mark for rounding to 84 and finding the mass number. Thank you for watching this video. I hope you found it useful. If you have any questions, feel free to let me down in the comments below.